Hey there, math fans. Dr. Andy Lovelace. In our pre-calculus class, we have various algebra problems thrown in at the end of assignments. We have a particularly challenging batch here where the variable is trapped. And so I wanted to say a few things about what do we do when the variable is trapped. We usually try to get a variable by itself by shifting things from one side to the other. We've played that game quite a bit. You know, if there's a 3x plus 2 and this is squared and this is 10, we shift things over. We subtract the 2. We divide by 3. We hit the square root. It is possible to get the x by itself. There's just one x there. Now, it's not possible for us to easily solve everything with algebra, but these ones we happen to be able to get the variable unstuck. So the challenge in step 1 is to somehow get these variables together in all of these. That becomes mission number 1. If we can expand in some way, somehow get the variable by itself, then we have a one variable equation to solve and we can use our tools we've been building. Okay, I would argue that this first one's a little different. This one, you can do a few different things. You might even notice that this denominator factors, or you might be suspicious that it does. Two numbers that multiply together to give you -8 and add together to give you -4, it exactly matches the other side. So I would argue that this one's a little different than the others. The normal strategy for fractions that I've been suggesting is to clear the denominators, meaning multiply both sides by any denominators you see. And the clever thing about this particular one, we could do more on that, but I want to talk more about the radicals, is, hey, that denominator is the same. So if you multiply both sides by this, you immediately clean it up. Now, I have noticed over the years that some people have challenges with thinking this way, meaning if I say I'm going to multiply this by this and put that there and put that there, I find that some people have trouble visualizing the cancellation that will happen. On this side, everything will cancel. It'll be, by cancel, I mean it'll be 1. And on the other side, the x plus 1 will cancel. Some students force me to write it there, but with practice, I hope by the time you get to calculus, you can say all that will be left is here. After I write this, right next to this, and cancel the x plus 2. Okay, so I'm going to do it again. This time the x minus 4 will cancel. We have 12. So that was a successful maneuver to untrap the variable in the denominator. Now you can expand out and it will be a quadratic. So I'm going to leave that. Okay, so on to the next one. Let's go upper right there. The variables are trapped, but we can handle this fairly quickly by squaring. So in all these cases where there's radicals, we're going to square at some moment, and we can do that right now. I would say we have isolated the square root, and so we're already at a moment where we could square both sides. So let's do that. Now the bad news is when you square both sides, you sort of trade off one problem for another. You now will have to FOIL that out, or as my students know, we're going to monkey face it out. So you're going to do this times this. You're going to do this times that. And away we go. So at that point, then you will have a quadratic. You'll get everything to one side. You'll do the quadratic formula. Now, there's a comment I want to make, so I'll take this one step further. 1/4 x squared, that's this eyebrow. The middle term is 3x, and there's another 3x, so in total it's 6x. And the last term is 36. Oh, this is interesting. This is a very common cancellation error here. These do not cancel. They become 72. So you're going to get everything to one side and use the quadratic formula. There is a note to be made here that is subtle. So usually when you do the quadratic formula, you'll get two answers. X equals something and x equals something. You have an added step here, which is to check if they both work. And typically only one of them works. So what is that about? It's about the following. So if I told you that a, the square root of a, was equal to 3, there's only one answer to that. And the answer is a equals 9. It's not a plus or minus situation. You can't take the square root of a minus. All right. So now imagine I say that b equals 3. And we start with this assumption. And then imagine we square both sides. B squared equals 9. And then imagine I say solve this. And you would get b equals plus or minus 3. So assuming that b equals 3 implies that b equals plus or minus 3. So there's a problem when you square, you introduce another possible solution that wasn't there. So the moment I go from here to here, I go, uh-oh, I might have introduced an extra solution, because now they would be equal if they both, if it was negative. Okay, I don't know that happens that first one, but it definitely happens in these other ones. All right, now for the challenge. I need to get rid of the radical. If I square right now, I'll have to FOIL this out. That's actually not bad. That is a way to go. I find that it's usually, in my opinion, easier to isolate one of the square roots. It doesn't matter which one. And I don't know if it's easier. I haven't thought deeply about this. I just am giving you a way. And then I'm going to square both sides. That will get rid of one of my radicals. And it might introduce new solutions. The other side I'm just going to FOIL out. So I have a 10 minus, or monkey face, this thing. I'm going to do this times that times that, this times this, and it's sort of bad news, but we can do it. 100, the middle term, the nose and the mouth, is negative 20 square root of x, because it's negative 10 and another negative 10. And then the last term is going to be plus x, because the square root of x times square root of x. At that point, you can see we've made progress. We're not done, but we got rid of one of our radicals. So the next step is to get the final radical by itself. So I think I probably would add it to both sides. That would put a 20 square root of x over here. I'd subtract the x from both sides, which would cancel the x. I would add the 20. So I think I get this. I did a couple different things there. And let me know if I made a mistake. I'm doing these on the fly. I just wanted to talk about ideas here as we did this. Oops, sorry. Okay, so then you could go a step further and say the square root of x is 60. And then you're going to square both. So I guess this ended up being nicer because everything canceled. But then you can say 3600. Now, I don't trust myself. I feel like I'd want to come back here and completely check anyways, just in case I made some silly mistake. So this would be 60. So that's a good thing I checked, because it doesn't work. So 120 divided by this is 6. This means 36. That sounds better. Square root of 36 is 6. Square root of 16 is 4. Success. Okay, the last one just has more to it, but same thing. Let's isolate one of the square roots. Let's square both sides. That gets rid of this radical. So you just sort of trade off and say, I'm going to try to untrap one of my variables and then go from there. So you kind of have this mission before you can even start solving. So now I have to monkey face or FOIL that out. This is why it just becomes, hopefully you're getting better and better at monkey facing. That's the first thing squared. It's double the product of those two things. Because the better you can get at that, the easier this will all get. And it's the last thing squared. So it's going to be 3t minus 1. Then you sort of take a breath. And then you isolate the square root again. So let's isolate. This is going to be 10, the square root of 3t minus 1. And then we're going to move everything to the other side. So this time it's 3t minus, so it's just going to become a t. And then it's 24 minus 2, so it's 22. And then we're going to square again. You can actually square right now and just call it 100, 3t minus 1, and then you're going to monkey face or FOIL this out. You can see where, part of the goal. 22 squared, I have to think about that for a second. It's a quadratic. Now you can get everything to one side and use the quadratic formula. Keep lots of digits till the end. That's the idea. If you have specific follow-up questions, we can talk about that in the discussion board, but I hope that helps.